How does machine learning coding differ from traditional programming? Have you ever wondered how machine learning coding stands apart from traditional programming? Let's break it down in a way that's easy to grasp. First off, traditional programming is all about writing specific rules and logic. Programmers create step-by-step instructions that the computer follows. This means the programmer needs to have a clear understanding of the problem and how to solve it. On the other hand, machine learning coding is different. It involves training algorithms on large sets of data. Instead of writing rules, the system learns patterns and relationships on its own. This means it can adapt and improve as it encounters new data. Next, let's talk about data handling. Traditional programming usually deals with structured data that has a clear format. It expects consistent inputs to work properly. In contrast, machine learning thrives on large and often unstructured data. The quality and variety of the training data are key factors that influence how well the model performs. Now, consider flexibility and adaptability. Traditional programs operate within fixed boundaries. If something changes, like a new requirement, the programmer has to manually update the code. Machine learning models, however, can adjust to new data and changing patterns. This makes them ideal for dynamic situations, like detecting fraud or processing natural language. When it comes to problem complexity, traditional programming is great for straightforward tasks that follow clear rules. But it struggles with complex issues like recognizing images or understanding speech. Machine learning is designed to tackle these layered problems by learning from examples rather than relying on rigid rules. Let's also look at outcome predictability and decision-making. Traditional programming gives consistent and predictable results based on the rules set by the programmer. Machine learning, however, produces outputs that are probabilistic. This means the results can vary depending on the data and the state of the model, offering predictions instead of fixed answers. Transparency and debugging are important too. Traditional code is generally easier to debug because its logic is clear and traceable. In contrast, machine learning models, especially complex ones like deep neural networks, can be harder to interpret. This often requires specialized techniques to understand their decisions. Lastly, let's discuss practical applications. Traditional programming works well for tasks with clear rules, such as calculators or data entry systems. Machine learning, however, is preferred for applications that involve recognizing patterns, making predictions, or adapting to new information. Think of recommendation systems, self-driving cars, or language translation tools. Understanding these differences is essential for anyone learning to code with modern AI tools. Machine learning coding often involves using frameworks and libraries that help with data preprocessing, model training, and deployment. This is quite different from writing traditional procedural or object-oriented code. Embracing machine learning means focusing on data quality and model tuning, while traditional programming emphasizes algorithm design and control flow. So, in essence, traditional programming is about fixed rules and predictable outcomes, while machine learning coding is data-driven and adaptable, allowing systems to learn and improve from experience.